Hello, hello. Oh my God, I almost start in Spanish. We were talking with Jose and we were chatting in Spanish, and I was going to say, hey, hola. But no, we are in the .NET show and switch back to English and more. Hello, everyone. Welcome to another session of the .NET Community Stand-Up. We are going to talk about AI. We are going to talk about .NET and mostly about the agent framework. I'm still learning a lot about agent framework. I really, really enjoy this. And today I was also I'm super happy because I have the chance to invite Jose. We know each other for 20 years, maybe, I don't know, a long time back when I was living in Spain. He was living also in Spain. We were war MVPs, both MVPs and more. And he worked a lot with what we are going to talk today, which is semantic kernel and agents and more. I use a lot of semantic kernel, but not in the agent side. But I really, really want to have someone who works in both sides so we can learn more about the migration, the opportunities. And he's also collaborating a lot into the repo of the agent framework. So I really appreciate that he's helping. So, hey, Bruno here, .NET, Cloud Advocate, and more. Jose, introduce yourself if you want, please.
Yeah, thanks, Bruno. As Bruno said, it's a long story already. So we did many events together in Spain. And yeah, what can I say? I'm author of several courses on AI, right, which are available in LinkedIn Learning. So I think, can you share the link, or should I share the link in comments?
If you want to share the link in one of our internal chat, I can put it in the.
I did already.
Oh, perfect. Oh, I didn't
Nice.
see. Oh, there it is.
So to be honest, I've been like since the beginning of Semantic Kernel playing and learning with that and doing a lot of POCs in my company. I also went quite deep with AutoGen, so I know both sides and I know also both teams. One of the benefits of being a Microsoft AI MVP and contributing to the projects, which I contributed to both as well, so I know them well. And now I started like 2 weeks ago to fully contribute to the Microsoft Agent Framework, which mostly I've been contributing on the area of workflows, which I especially like.
Yes. And hey, by the way, I was migrating a couple of big scenarios that we have from semantic kernel to agent framework. It's straightforward, I would say. Most of the 99% of the concepts are the same, so you only need to change namespaces and a couple of lines of code. I realized today that we still don't have the magenta. I always say it's wrong, but
Magentic.
we don't. Yes, we don't have still in .NET yet. I didn't even know the story that this one came from AutoGen. So that's the place
Mhm.
that the whole the Magentic process, workflow process idea or type came from there. But it's a working process, and we have a lot of people asking, how hard is the migration? How can I migrate here and there? So we are going to talk about workflow. We are going to talk about migration, but let me show you a quick overview. And by the way, hello everyone from Egypt, from Canada. I don't know if you are in Spain today or you are in Switzerland. Where are you?
I'm in Zurich today in Switzerland.
Perfect. You are there. So hello to everyone, and let me share my screen and let's start to take a look. By the way, Agent framework, it's fully documented. You can see everything that we have and we don't have yet here. So we are coming. We have a couple of coming soons, like in example, the Magentic workflow here in .NET. But this is the place to go. And we are going to share later the repo if you want to do your PR, report issues, and more. We really, really appreciate the help from the community here. As I said, I use a lot of semantic kernel. This is going back home. For me, I use a lot of semantic kernel at the beginning when generative AI started, because it was very, in the .NET world, it was a very easy way to start. So I use it a lot. I later switched to another framework, and then Microsoft Extension for AI basically unify everything there. But Semantic kernel was also supporting agents and supporting agents in different ideas. And the whole idea of an agent, we talked about this last week. I am not going to share slides and talk about agents, but the whole idea here is that when we have an agent, this is the ABC of what we have. And by the way, I am creating here an agent using Azure OpenAI models. I think I am using a GPT-5 mini model, can't remember. Don't do the API key, do credentials. I use both default credentials or CLI credentials or whatever. I use both to talk about this. But this is the ABC of semantic kernel with agents. That, and correct, Jose Luis, keep me honest here, just in case I say something that is not like this. In the kernel world, you start with the kernel because it's in the name. So this is what we have. Then you add services. The service that I am adding here is the chat completion service with Azure OpenAI, but you can add Olama chat completion, OpenAI chat completion, and more. And then when you have this and you can provide more services, embedding services, vector search, you can do a lot of things here. And then you can create an agent. And the agent is literally 3 lines of code where you create, in this case, it's a chat completion agent, and it needs to have a name, a set of instructions, and the kernel. That's the important part. Does this make sense, Jose? Did I miss something big?
No, that's pretty much it. It's quite correct, yes.
Yes, and once you have this, the next step is ABC. So here what I have is the 10, 20 lines of code where you create a chat and you basically start to chat with the agent. So let me do this startup process and let's start this. And what I want to share here, and I do this, is that by default, when you start to work with an LLM, you don't have memory. The agent is not going to know who you are. So when it starts, did I start the right one? Yes, I say Semantic Kernel agent. So when I start, I will have here questions. So I will say, hey, my name is Bruno. So the agent is going to respond to me. This is, hey, Bruno, nice to meet you. What is my name? So the agent, because we don't have memory right now, we don't know, the agent doesn't know what happened here. So I need to implement the memory. When we were working with large language model, what we usually have is kind of a collection of messages where we have the assistant message, the user message, the assistant message. At the beginning, we had the system prompt or can't remember the name. But the idea is that they don't, in the LLM world, we don't have memory. When we work with agents, there is an easy way to do this, which is let's create a thread, because this is what we use here, and then we pass the thread when we start to talk with an agent. So I am going to, when I do the invoke async, when I'm talking with the agent, I am going to use the thread. And with that said, with just one line of code, what I am going to have one more time, if my agent, where I'm going to say, hey, my name is Bruno, I will have the reply right now, nice to meet you. And if I ask the name, the agent should know that, yes, your name is Bruno, how can I help you today? So this is kind of the ABC when you start to do agents. One of the cool part of agents is that, hey, you can literally add memory to your agent, another feature, with the concept of a thread. And the thread is basically where you have all of your conversation. How different is to do this in agent framework? It's the same. I mean, there is a big change here that we don't have kernels. So this is how we create an agent in agent framework. Oh my God, this is going to be hard for me to do this agents. But I am creating a Azure OpenAI client.
Bruno,
yes.
If I may, one thing I like about this change is that here we have a lot less boilerplate, because we simply add the connection and everything to the chat client and concretely to the agent, right? So before we were adding the tools in the kernel, and then we had to add the kernel to the agent. So it's quite a bit cumbersome sometimes, and you have the risk of mixing things where you should not. And in the Microsoft Agent Framework is a lot more streamlined. So I like that.
Yes, and by the way, it follows kind of the Microsoft extension for AI pattern. That's what we want to have, that every AI library in .NET should follow. So it makes sense. But yes, we don't have kernel anymore. I miss the kernel, by the way. I like the idea of kernel, but when you get used to this, it's easier. But still, we create a client, and then a chat client will create an agent. By the way, there are 2 ways to do this. We can create a chat client here. This is what we see in the first line, that implement the iChat client from extension, and then we create a chat client that use the client and then have an instruction, or we can say client create agent or something like this. I can't remember. There are 2 ways that we can do this depending on how you code this, but everything else is the same. And of course, here we have the Q&A, and of course here, if I run this again, oh my God, I'm going to write my name 20 times today. If I run this demo again and I say, hey, my name is Bruno, I am going to have the hello Bruno or whatever from the agent. And if I ask for my name again, Oh, no, I only have this. I only have my name is Bruno. What is my name? If I ask for my name, the agent won't know my name. So I need to create a thread here. And what I found here is that I don't need to create a thread as an independent object. I will have a nice Copilot suggestion, which is almost there. It's almost there. It's not like this, but let's do var thread, and I am going to do agent get new thread. And with that, and now I have here somewhere here in the user queue and thread, I will have the not here, sorry. I will have here the support for having memory and more. So again, it's easy. Hi, my name is Bruno. So again, it's easy, but as we saw in the two lines, in the two pieces of code, what is my name? It's very similar. It's very similar. The concepts are the same. The thread is there, the agent is there. You need the chat client, you need the chat completion. So it's literally, basically, okay, I will change 10 lines of code for 8 lines of code, or I will change 20 for 5 or 25, or I don't know. But the whole idea is that the migration for agents should not be very, very complicated. I'm going to show a couple of other scenarios, also working with local models and with tools, but time to stop and check the question. I see a lot of hellos here. We have a good question here from, oh my God, I am going to say your name very, very, very bad. Ugochukwu. I hope it's fine. Sorry if I said your name bad, but it's ready for production. It's in preview right now. So it's going to be GA soon. Don't know the date and more, but we are working super, super hard to be ready for production. But my advice will be get ready for this, because it's going to be...
Bruno,
yes.
The target is Q1 2026, just so you know. So they are aiming to do that. So it's a bit of a 3 to 4 months time frame.
Yes, we have November, December, and we are already on Q1.
January.
So yes, 3 months, 4 months, we are ready. We are there. But all of the efforts that we are doing and more are focusing on agent framework. So I will say again that focus there if you want to get them this. So I don't know. What do you think, Jose? Does this make sense? These super simple 2 lines of code
to me, it does.
Are easy to use?
It's a lot more modular. So on the agent ecosystem, so we can plug a brain, we can plug as well tools. The thread by default brings the memory and the chat history together by default, which is very important. And also you can override it and provide your custom implementation of the memory for the agent.
I saw that. Somewhere here in the documentation. I didn't play around this, but I saw that you can have
agents. It's at the bottom.
Yes, in the persisting and resuming, you can add memory
adding memory to agents.
And you can.
Yes, this one.
You can implement your own context provider, so you can store your messages in your vector database and search. And there are a lot of things that you can do here. I like it in the sense that we know that we get to a point that AI is super powerful and more, but we also know that, hey, how can I extend this for my specific scenarios? And adding memory to agent is something that I think it's, even if by default, as Jose mentioned, it's super well covered right now. The extensibility part here, it's super important. I need to find the nice, if someone has a cool scenario here to share, let me know, and we will try to figure out how to do it, make it public, and give the right kudos.
I in fact do. So one thing I did last year in one of the demos, and also in a couple of products that I built for me with Semantic Kernel, is a tool that could take notes. I like note taking, so I thought, why shouldn't we provide this ability to agents? So I provided a tool that could write notes and then retrieve the notes whenever, and that was serialized on text on a file, right? So it was super easy to, hey, open and start a new conversation. He reads the file and already knows what we talk about.
Yes, and again, it's for all of the Microsoft Extension for AI and Extension for AI abstractions, and we have abstractions in a lot of parts. So extensibility is key here. Let's go back here to other samples before we start to talk about workflow. Sorry. So, hey, how about Ollama? People probably know that I'm a big fan of Ollama. Ollama, if you don't know, it's a local You can run local models in your machine. So there are a couple of tools for do this. AI Foundry Local is also very good. I need to do my AI Foundry demos soon right now. But you have AI Foundry Local, you have Olama, LM Studio, and more. So you can run models locally. I like to run Olama in Docker. So this is my Docker instance. I started Olama, and if I go here and open a terminal, this is the model that I have locally. So I have Llama 3.2, I have all mini LM, which is an embedding model, 5.4 mini reasoning, DeepSeek, and the OpenAI GPT model. So I have all of these. And hey, if I run this SK agent, we are going to do again the AVC of Semantic Kernel. Let's first create a kernel. In this scenario, we're going to add the chat client, not Azure OpenAI, not OpenAI, a local one. And then we create an agent. And then the agent, I don't have memory here, yes. And then we have a kernel with memory and more. So super easy. I'm just going to run this so you can take a look that it's running locally in Olama. So when I have this, let's do hi. So we are going to see here that in the Docker, it's starting to load the model, and the model is in memory. It took a couple of seconds. This is a small model, Llama 3.2, so 4 seconds and it's ready. And I have here my yes, agent, hello, and more. How is the same code in Agent Framework? So literally, as we saw before, we create, in this scenario, no Llama Sharp client, and then we create a chat client. Again, as Jose mentioned, less code, easier to read. Everything else is literally the same. I don't have threads here, the only thing here, but this is also running here, which is cool. And again, if you switch to another provider, to OpenAI, chat, or whatever, it's the same. Create the chat completion and then create your agent. Where I started to see differences is when we start to talk about tools, when we start to talk about how we can invoke external tools. And yes, Johnny is saying local models. Yes, I'm a big fan of local models. Probably a lot of people knows about that. But let's take a look at, this is literally the hello world of functions in Semantic Kernel. I literally copy and paste this from the documentation because the samples that I have are too complex to explain something. So what we have here, we have a class, the weather plugin class, that has a couple of functions. These functions are get weather for a city and get forecast for the city and the days. Everything is hard-coded. Yeah, amazing. But what we have here is basically for each one of the functions, we have a name, we have a parameter. The name and the parameter have a description. And we have a decorator here that specifically say that this is a kernel function. So when we use a function in Semantic Kernel, we need to specifically decorate the function with kernel function. That's correct. Jose, do you know this? Or I think yes, but I want to double check if I'm missing something.
Mm-hmm. Yeah, that's fully correct. So it's attribute or description based. So,
yes.
Yep.
So the main difference here is that when we create the kernel, what we have here is once we have the kernel, we add this new plugin here. And there are different ways to add plugins. You can add plugin from files, you can add plugin from types, so you can add, there are different ways, but you need to add these plugins, these tools specifically to the kernel. And then when you create an agent, this is also a difference here, you need to specify that the agent will support function calling, because at the end of the day, this is all came from function calling. And I think we talk about this 20 times in the .NET and AI community stand-up, but basically it's the model that will know that need to call a function. So we say here, yeah, you know what? In the parameter section settings, do the behavior automatically when you need to call a function. So with that, what we have is literally the same. We have the agent invoking the method, and when I have here, what I can ask is a question like an example. I don't know. Tell me the weather in Toronto, and because it's hard-coded, the weather is going to say to me something sunny, 72 Fahrenheit, and this is what we have here. And by the way, if I remove this and ask the question for the weather in Toronto, the model will say, hey, I can't access weather information, so I don't know what to do. In Agent Framework, I like that the code is similar. So first of all, we will have a function static function here, get weather. Again, everything is with description, but we don't need to decorate with the kernel function. Just the function here. We have a static get weather. And then when we create our chat client, and when we create our agent, this is the moment that we are going to add tools. And this is a specific part that we probably, if someone is interested, we can talk a lot in a future episode, because there are a lot of different ways that an agent can use tools. We can use a tool like this that is literally is an internal function of the program. But we can use MCP tools. We can use tools like Code Interpreter. We can use tools, if we are talking about agents in Foundry, that are going to call, I don't know, they are going to be connected to a vector store and going to do a vector search. So the tool part here, it's super, super important, and is very, very straightforward in the sense that how you can do this. And I really like it. I can show a couple of samples, but I really, really like it because, again, we create a chat client and then we focus on the agent. And the tools part is where I started to see, again, the code is similar. You say function factory, create, and you pass your local function. But at the same time, when you start to span to agents, to really the agent world, it's boom, oh my God. I was writing code in a very natural way, and I really, really like it. But once again, I don't have any experience in semantic kernel for the migration to say how big is the change here. I don't know, Jose, if you work with these two approach and you have some opinion here.
Oh yeah, I do. I have a strong one. You may not like it. I like it. It's more simple. So, for example, we don't have to put the attribute that this is a function, right? So, I mean, I think it's obvious. If we try to add something as a tool, it's a tool, so it must match it, and we only put the description, which is what the model uses to call that tool.
Yes.
The thing that I don't like is that I have not yet seen, so I may be wrong, but on the examples, we have AI function, factory, create, and then we add only one function. I like the semantic kernel way, which is you can create a class filled up with similar functions. That was the
Yes.
concept of the plugin, and you can add all of that in one go. So it's a lot more simple and less verbose than adding them one by one.
Yes, I get your point, because here, what you mean, if I have this and I want to have more than one, what I need to do is something like this and like this and like this and like this and like this. And hey, if I have, as you mentioned, if I have a class that have 25 functions and they are all plugins, I want to add everything from there. Hey, I like that. I like that as a room for improvement in the stuff that we can do right now with this. Hey, something that we can add a PR for there. We have a question here, which is a nice one. So, in the context of the thread that is stored in process or as application memory with the foundation model. No, it's going to be stored in process as far as I understand. I need to check the code. That's the good part, that is open source, that we can take a look there. But in example, if we are using an agent that is an Azure AI Foundry agent, the thread is the thread support that is in AI Foundry. So when we create a thread and we start to chat, it's going to be stored and it's going to be managed by AI Foundry. So I need to figure out, I need to go deep here in the different other implementation, but I will say that is in application in memory right now.
You're fully correct, Bruno.
You're taking a look?
No, I know. So I know that by default it's in memory.
Yes. That's what I was thinking. And that's why we also showed before that if you want to extend this to do something else, you can extend it. And as Jose mentioned, they have the option to do more, and there are plenty of things that we can do. So that's it. If you want to find, because we want to do half and half of migrations and framework and workflows, if you want to know more about this, of course, we have a lot of samples, and these samples are part of the generative AI for beginners.net. And I know I always talk about this, but we have lesson 6 here, where we are starting to add more and more agent frameworks. And I am going to add the previews and the semantic kernel and agent framework, so people have the two options to do there. And we are also working on a very big set of blog posts and more when we explain everything. But here you can find literally this, where you have a couple of simple agent framework scenarios using GitHub models, using AI Foundry, using Olama, and then you have more complex scenarios, like in example, agent framework calling Hugging Face MCP if you want to generate an image, or you have a multi-agent. And this is something that people really, really like it to have it here, where you have a set of agents, and you have the first agent is going to be a researcher that is going to live on AI Foundry. The second agent is going to be a writer that can live also in a GitHub model, and the third one is in a local model. So you manage the call between all of the agents, and basically what you have here is create one agent, and then when we have here at the end is the sequential workflow where we have researcher, writer, and reviewer, and we run everything here. But hey, someone asked the other time if we use different LLMs? Yes, you can have agents in the same platform using, I don't know, GPT-4.1, GPT-4.1 mini, and GPT-5 mini. But at the same time, you can have agents running in your machine, in the cloud, and all orchestrated with all of this. And this is the perfect segue to start to talk about workflows, because I know that Jose knows a lot about this.
I've been playing a bit.
So, and the final here is the one that I just said, that we have a multi-model. So if someone wants to know more, that's the repo. We are open to questions and more to what we have. Janisco said that it's time to upgrade their old bot framework to Agent SDK. Yes, I mean, if it's still working, I will probably don't do anything, but it will be nice to keep it up to date just in case, to avoid a very, very, very big migration. So, Jose, do you want to share your screen and we start to take a look at workflows and more?
Let's do that.
I will advise, while you are preparing your stuff, I will advise everyone that I was taking a look here to the documentation, to the official documentation, and the workflow part, it's very, very good. It's very well. I am not a reading person. I like to see the code, copy paste, or write similar and do everything. But this explanation of workflows in agent world and more, it's very, very, very good. So I will advise everyone to spend some time in the official documentation to take a look at this.
Okay.
So, and this is also where I saw that the Magentic came from. Magentic 1 from the AutoZen, and it's coming soon. I did my migration sample for all of them, and then probably there is a PR they are ready to be implementing the Magentic anytime soon. So, do you want me to share your screen?
Yes, it's okay. I like night mode, so.
You can tell when you are sharing and I am sharing. That I like it.
Okay, good.
So we don't get confused.
So let's take a look at workflows. I think it's a lot better here the overview. So basically, and what is a workflow? I hope you're familiar with graph notation, graph databases, and workflows. So basically, a workflow is when you can orchestrate different agents or different things that you want to do. In this case, the concept of workflows in Microsoft Agent Framework is such of a business workflow where we can mix in agents. So you can create functions that do something as part of the workflow. These are called executors. So for example, this image speaks for itself. We can have here something that writes or generates some text or asks the user for something. Here we can have an agent doing something. Here another part of code that processes the output of the agent and does whatever. So we could have an agent generating a database schema based on an input here, and here we validate, here we check it's good enough, and if it's good enough, we simply can deploy here. Does it make sense? So it's super, super powerful. This is kind of, you have the power of doing whatever you want in code, which gives you, well, unlimited possibilities. I'm maybe not exaggerating when I say that. So let me show about it a bit. So executors, I already mentioned, this is a fundamental building block, right? So executor is everything which is in there. When we add an agent, the agent is wrapped in an executor without we noticing, right? And edges is what we are, how we connect the boxes together. how we connect the executors. We have direct edges, which go from one executor to another. We have conditional edges, which is, hey, if one executor has an agent and this is like a gated that has to prove, is this good enough? Do I approve the budget or no? Then I can trigger it to go and send an email in other case, and otherwise have it approved. And I can implement that in a business application and it works. And then altogether, edges and these executors create workflows. This is very simple. So we have here, we use the Microsoft agents. I think it's agents.ai workflows. So this code which is here is not always correct and may be deprecated, so it needs verification. I recommend you to go to the samples. I'll show you where they are in a moment, because this is not always correct. And then we create the executors. Usually it's a single function, and then we build the workflow, right? And we put the starting part, because every workflow needs a piece of place to begin with, and then we add edges. That means from processor, we go to validator, and from validator to formatter. And then we build it, and we sometimes give it a type, right? But I think the best thing is to show it to you. So I have some code samples that I've been playing around. And I think I have these, which is a basic sequential, which shows a content production, which is very simple, that I prepared it for today. So I have here a very simple code where I have these, what I say, Microsoft agents.ai workflows. That's the right namespace. And then I create the chat client. In this case, I'm using the key credential. I'm based on the old school. It's more comfortable, so I don't have to log in every time, right, Bruno? And then I create the different agents. In this case, where I have agents. So I have a researcher, give it, hey, you have to research. Then I have a writer. So I create the child client agent. I don't need memory. It's overrated. In this case, it's a one go. I don't have a multi interaction here. And then I have a editor. So follow with me. I have a researcher, writer, and editor that will correct and improve it. And then I build the workflow, which I can build. Bruno,
Sorry,
yeah,
Jose, can you zoom a little the code?
it's good.
Yes, perfect. Thanks.
Nice. Thank you. And I build something which is the sequential. So I build a sequence of these three agents. This is something special, which it creates internally the different edges, so you don't have to. So it makes your life a bit easier. If we go here, we can see that there is some orchestration, there is a sequential. We have the overview of the different elements, and here what I'm writing is a sequential, which is a sequence. So I have here the first agent, second agent, and third agent. I have the researcher, I have the writer, and the editor. That's it. And of course, there is a Magentic one, which is not yet implemented, but it will come in soon, as Bruno mentioned. So let's back to the code. Here, I think the best thing is I show it to you at the end. I build it as a sequential. So this is the same that generating on your own the different edges, but this is easier. So I use this in this case. And then I ask it to generate a LinkedIn post about the benefits of using AI, blah, blah, blah. I get the initial messages. So I will ask a few things with this topic. And then I run it. So we can run the workflows in run sync or run stream async, which is what I'm doing here. And then I simply have a loop to process this. I plan to put all this code later on, but it has some samples, not all of them to work properly. So I'm creating a ton of issues. I can show it, but let's first this demo 04. Let me activate it and show it. You have any question? Meanwhile, I'm doing that, Bruno, on the
Yeah, there is one here, and there are two here. First, Mike, we're going to get yours about OpenTelemetry soon, and then we have Future Mulenga is asking about how we can best use the agent ERP system. So that will depend a lot about your system, but I will say that agents and ERP, they can do a lot of things like automatically, I don't know, I'm making this up on my up to my mind. Every night you have agent that summarize some work, summarize a lot of stuff. I think we have a lot of use cases that we talk and we share in the Microsoft.com/AI, where you can start to see real user scenarios where you can take a look at this. So, hey, this is something that you can have there. And the other one is around OpenTelemetry. We are going to talk about this. I'm going to show you example because there is something there. I don't know how deep do you want to go with this. And the third one that we have before going back to you, Jose, is how long does a typical workflow take to complete? 1 second to
Well,
22,000 years.
typical workflow. That
Depending on
is
the
what
workflow.
typical workflow.
Yes, but this is also important. We have samples where we have the agent framework support workflows where you have human interaction. So you can kind of freeze a workflow, wait for the human to do something, then the human does something, and then revive the work, get it back to life and more. That's not the right term, but I can't remember how we do this, how we talk about this. But there is no typical time for this. It all depends on your scenario, but we are supporting a lot of places where we can do this. Jose, back to you.
Yep. So I have executed that. So let's go over the output, right? So you don't have to follow that. So it sets the agent, researcher, writer, editor. It builds the pipeline. And then we have the researcher output that goes into the writer that writes it, and then to the editor. And then we have a final node, executor, which gets the final published content. And that's it. Basically, it's three specialist agents, each doing one task brilliantly because agents excel at concrete, very simple, focused thing. So if you give them the tools they need and the proper prompting, then they will behave a lot better. Talking about prompting, you can check my latest course, which is about prompting for AI agents in LinkedIn Learning. So it's being accepted quite well. It's about 9,000 of the last 3 weeks persons that did that. So I think that can help. It's a bit not using technical words, but showing some advanced things, which I like, trying to avoid using some concrete topics. So in short, you have seen how easy it is, right? It's super, super powerful. It just, the key here is in these building the agents or the executors and then simply chaining them together on this part, this build sequential. I hope everything is clear. If anybody has a question, I think Merdan, you have a question here. There are any plans for UI for building workflows at runtime similar to NAN? I understand that this is like a drag and drop. I know that there is one component which kind of has been look in AI. I think it's the AI toolkit for Visual Studio Code, but that's not yet public. I don't even have the access to the preview. Yeah.
Yes, there is something there. I don't know. I don't know if when or what, or I know that a lot of people is asking for something like this. A
Me too.
visual drag and droppy scenario to build agents. By the way, maybe Power Automate will help you because you have a visual whatever and you can ascend the Power Automate flow later. There are a couple of things that you can do there, and they are interesting. Let me go back before talking about this to one of the questions from Mike about OpenTelemetry, observability, or evaluation for workflow. I don't know about workflows and OpenTelemetry. Let me start there. But let me show my screen with a little, Jose, and let me show something.
Sure.
So we have this. Where is my running demo? There it is. So we have this AI chat template that we can use, and we've been using this for a long time. Let me show you here. Basically, you do AI, you do a new template in Visual Studio, and you have one of the templates is to create a chat application, and the chat application is something like this, where you basically have a chat, and you also have RAG and more. A couple of samples that we have in the generative AI scenario use Aspire with this. And the nice things about using Aspire is that in this one specifically that we have here, this is a multi-agent scenario where you have a couple of agents talking between each other, and you also have this, which is a couple of functions that are added as functions here to the agent, where we have a client create AI agents, so we can use this later, and it's going to have function calling. An important thing that I learned when I was doing this: if you don't have a description here for your function, the name of the function should be good enough to understand what is the function doing. But please add the description to your function and to your parameters. I am not doing this, so that's bad. You need to do this in another way. But what I have here is a main agent that is using function is going to call other agents. I need to switch this to workflow. I am going to do a workflow version of this. But what we have here is a coordinator agent that is going to use a researcher and a writer, and then it's going to do this. When I ask a question, let me go back to the chat so you can take a look. When I, no, not this one, this one. When I ask a question like, tell me about the GPS watch, this is a document, it's going to write a full set of code, text or whatever in the response. And then it's going to even give me here the citations, where this information came from. So I can go here, came from this PDF. But what I like is that at runtime, because we have OpenTelemetry enabled by default, and we have OpenTelemetry as part of Microsoft Extension for AI, Microsoft Agent Framework, and more, we have a lot of telemetry that we can right now analyze here in Aspire. So in the traces, if I go here to the traces, I see that this has been working a lot. So let me search for OpenAI. I can see everything here, and this small dot, these small stars or whatever, are the AI view, because we have the telemetry detected that we have generative AI information here. So we can take a look here how it all started. So we have a system message, we have my question, and then we have a couple of tool calls. Remember, this is not workflow. I need to switch this to workflow to start to see if I can have a full layout of calls between each one of the agents. But I know that the first action of the first agent is make a tool call that is going to call the researcher agent. So now I have here my researcher agent asking about GPS watch, and this is going to do a search about GPS watch. And then if I start to move here, I have some embeddings called here, so I am converting to embeddings, and then I have a big one where I have, this is the research specialist that is going to search about watches, then it's going to search for GPS watch, it's going to find a couple of information in the vector memory, and then it's going to provide this response, which is a standard response, but what you see here at the bottom is kind of a trick to have the citation, so we can later display the box equity citation. So next in the pitch is, okay, what we have here. So the researcher did that, and now we ask the writer to write an article based on the information from the researcher, and we are going to have everything big that we have, and also include it doesn't include right now the citation. So that's why one of the rules somewhere here is write or comprehensive or whatever in the tool calls, and we will have the citations, and we have the full information that, not in this one, in the next one, I don't know, somewhere here in the last one, it's include the citations at the bottom. And no, this is the last call where we are suggesting follow-up questions. But you can have a sense of the trace of what is happening here. You can have a sense of everything happening here. By the way, this is all came from all of the orchestration tool that we have here, from this ChatGPT Mini to this ChatGPT Mini to this ChatGPT Mini to this, which are literally, I need to figure out a way to display the name of the agent here. There should be a way to do this. I need to work with the Aspire team to see if we can add this information here. So the telemetry and the data is there. We probably need to figure out how to show this. And by the way, I am going to create literally one example for this using workflows, different type of workflows, so we know also how to read and show. I don't know if these mics kind of help. So I will say that the info is there. I don't know yet which is the best way to show this. And I know that visualizing, everybody's talking about these nice charts where you have an agent calling to another agent, getting a branch to call two agents. we should get something there anytime soon. I don't know how far we are. But hey, this is all. If you want to run this and take a look, this is in the Generative AI for Beginners, Agent Frameworks, source, and this is the multi-agent sample. This is the full multi-agent, which, by the way, have this crappy chat app20 demo name. I need to change. I need to put a more formal name here for this one. But the multi-agent is the one that we have. Oh my God, we have a lot of questions. Do you want me to go back to your screen, Jose? You are on mute. Sorry.
All right. Yeah. By the way, if you can, yeah, sure. I'm showing here the repository.
Oh yes, please.
So there is this issue.
Oh, we lost. We lost Jose. Something happened there, and we lost Jose a lot. There it is. He's coming back. We lost you for a second.
Yes, but I'm back. Let me share again my screen.
Yes, and Janice was saying that the devui for Python, it's there. We are figuring out the best way to bring that to the .NET world. Still, no, there are a couple of ideas. I like to see people who are much more smarter than myself, people like Jose Luis and more talking about this. So it will come in one way to the other. We still don't know how, but yes, it will be. We will have the UI for something similar to the Python.
I have a theory, which is if we add enough pressure, this will happen sooner. And you know how this works because now.
Go for the repo and ask for that. And
yes, exactly. So I share with you, Bruno. If you can share it in the comments, can you share it in the comments because I cannot. The link. I ask everybody listening here, or if you listen to this later, please go in this issue and say, "Hey, I want this too." Right. So that would be super cool. And there is a PR. Oh wow! Yesterday. So it may be sooner than we expect. We have to see. But this is the way to see the workflow executing in real time, right? Yes. So I'm very visual. And yeah, coming back to here to follow up on what you were talking. So I'm talking now about observability in in workflows. There is this link. I also share this just before the latest issue, right? So you can check it. I think it's kind of nice. It's very similar to see that, and it's mostly for workflows. So observability is enabled for agents and for workflows. I think it's not that bad. To be honest, I have not yet played with that myself. But yeah. Also, there is one question in the comments that I like to respond because my next demo goes on that. Embedding, from Mike Holzer. I hope I pronounced your name properly. I will repeat it loud. Yeah, I'm aware, the agent level staff, wondering if there is standardized spans for superstep and other workflow boundaries. So yes, there is. And I made a demo for it. The demo is already on so this is demo sub workflows, right? And I contributed that, so you can find it in the original repository. But basically, what it does, it is at the moment getting, well, I'm generating in a bit of similar way. I'm getting a reverse function and using that as executor, which is not defined publicly, but if you want something very simple, you can do that, right, with lambdas, which I particularly like. It makes things simple. So I create a few executors here. This is mostly code, no AI. Sorry, Bruno, no agents. So I'm here simply creating some uppercase or some reverse, and then I use the workflow builder, starting with the starting point. The node that executes starts with so what is the first node on the workflow. Then I edge from the uppercase to the reverse executor, from the reverse executor to the append, and then I end with the append executor. Very simple. And also, this is not the best, but it's something I like because I implemented a workflow visualizer for the process framework in Semantic Kernel, and I'm helping out here too. So yeah, so you will see I'm working on that to make it bigger. And then we have a sub workflow that we create with configure sub workflow. At the moment, something called executorish, but this may be deprecated soon. So this in Python, for example, is called sub workflow, which I think it's a lot better name. So I guess at the moment, one of the persons of the team is working on changing that. And then we have a workflow in a workflow. So this is exactly what you might ask for. So you can package them. And then you can use them as any other executor here. So I'm adding here sub workflow executor and then post process executor and whatever. So to see how this runs is, okay, it's demo 05. So let me run it. Sub workflow executor. I'm not sure I have it. Demo 05. I said 5. I don't know how to write. Okay. Let me check the name is proper. Yeah. Because IntelliSense, where are you when I need you? Yep. There we go. Sorry for that. And if I execute it, have a multiple screen, so I have to drag this into, right? So the first thing I do is I like to draw a flowchart of what I'm doing. And for that, I
That's a
use,
mermaid?
yes, it's mermaid
Cool.
and dot diagram.
Oh, that's new for me. I heard about this, but never use it. I only use mermaid.
Okay, wait. There is this tool which is in the framework, which is here, print mermaid. So it's on the workflow. So it's an extension function, right? That basically it's doing this. That's it, nothing more, very easy. So if you can take a look at the code, it's just very simple. And if you want to contribute, there are some issues. Some of them I created for doing that. So let me bring that in back. So if I get that, so this is the sub workflow. You can do this. Let me bring that in. This is from another workflow. So if we have time, I can show you this other workflow, which is a bit more complicated, but shows everything you can do in a workflow as of today. So if I select this and put that, this is our sub workflow.
You have the upper, then the reverse, and then the append. Hey, I like it.
Yeah. And then this is the main workflow. At the moment, another thing I have asked or created an issue is that when you print a workflow, which contains a sub workflow, the sub workflow does show only the box. It does not allow
It
to
would be nice
go
to have
in.
everything.
Exactly. Yeah. And Mermaid can do that, and a dot, which is for visualizing graphs, can do that as well, right? So at the end, if you want the less interesting thing, this is the execution. I'm printing everything. Hello, workflows. Then I put it in uppercase. Then I append a suffix, which having change it a bit, and then a post process, which I put final in there. So it's a bit nonsensical, but it shows how a sub workflow works, which I hope it makes sense and opens a bit the eyes. So we have this composability, and it's fully implemented. I think this is also in Python, but in .NET is pretty cool.
Yes, and by the way, Mike have a question, a note, not a question, the saying that the observability is not for in the documents for C#. I know what you mean. It's in the user guide. We don't have observability for C#. It's in the tutorial. So I literally have a note here to talk with the Learn team to say, let's complete also that part because we have that part in .NET. We are missing that. Remember, everyone, that this is in preview and this is kind of new. 3 weeks, 2 weeks, can't remember. So we are still working on that. So thanks for the heads up on that. And hey, I didn't know about this the sprint to the mermaid stuff. So I'm going to give it a try. I'm literally migrating one of our big demos for this, and I need to figure out how to add this into our flow. That's super cool.
Yep. I think.
Oh, that's a good
Bruno.
question here. I want to have your point of view.
Bruno,
Unit testing.
Can you share the second link I share, the one about observability? I can paste it
Yes,
again.
I literally shared it before, but let me share it again.
Yeah, because I see that Mike Holzer was asking for it again. So I don't see the .NET docs for workflows,
There it
just
is.
Python. Yep, there we go. Thank you, Mike.
And as I said, do you have the documents there? Oh, we're getting to the end of the time, so no, we only have 3 more minutes, so no problems there and more.
Okay. There's one more thing that I want to show, which I think it's concurrent workflow mix. Mix agents and executors. This one is a pretty cool thing, which at the moment I'm mixing executors and agents, which they don't go well together because you have to build like a glue in the middle. So you have to put together different agents and converters, because one is outputting a string or a custom type, and the other is taking iChat. So so I need to convert them. So if I go and see, for example, a string to chat message, right? This is one of the converters. Is I'm transforming a string and outputting an array of chat messages, basically, and then emitting a turn token in this case.
That's
So
nice.
yeah, this is still, I think, I'm not sure if it's already in there in the repo, but I think I already contributed. Oh no, wait, I should put it. Not sure if we have the time, but I think this is demo 07, so let me comment and show it. Wait, no, 07. Yeah, now IntelliSense rocks. All right, and let me bring this here so you can see what's happening, and let's look at this. And if we, this is what I'm doing, right? So this number is a different agent, then a synchronization, another agent, and the final output.
That's cool.
So we can mix them. Yeah, this is another issue I have submitted, which is give them proper namings, because this, when I see this, I don't get it, what it means, right?
I am doing the part with the agents from AI Foundry, and I also realized that the IDs that I get are the agent ID, and I want the agent name for a couple, something similar here. So
Yes.
I get your pain. Hey, sorry to interrupt, but we are getting to the end of the hour.
Yep.
Oh my God, we already have some other stuff to talk in next editions. So I really like it.
Cool.
And so, hey, let me stop sharing your screen. I will say thanks to everyone who give us some feedback and give us amazing questions and ideas to move forward with this. I want to say also thanks, Jose, for being here. Probably the next time that we are doing this together, you already have your new agent framework course or training or whatever up and running. I hope so. Happy to help. And I don't know, anything else that you want to share at the end?
No, thanks for inviting me, and anytime. So I'll be playing, contributing. I recommend you to get involved with the repository. It's open to everybody. It's an open source project. The team is listening. They are fantastic, very open, very willing to help. So it's also a great experience and very motivating to be able to contribute to one of the top leading and bleeding edge agentic frameworks. So thanks again to you, Bruno, and to the full team.
This is where we want to have here, where we want to do, and we need to learn for the next couple of months or so. I don't know, probably year. I hope it's a couple of years. Hey, thanks everyone. Thanks, Jose. See you all next one. See you in a couple of weeks. Goodbye.